All right, hello and welcome. Let us get started from where we were last time talking about files. But just before that, let's remind ourselves about the midterm. It's happening on Wednesday. It's going to be on Gradescope, and it'll be available starting at 10:30 a.m. Okay, so you should be able to refresh the page at 10:30 a.m. on the 22nd on Wednesday, and see this midterm one appear for you, and you can start it. Okay. So you'll have 24 hours to complete it, remember, and once you start it, you have 80 minutes to finish it. So you need to start at least 80 minutes before 10:30 a.m. on the 23rd, because it lasts until then, right? But I encourage you to take it during the normal class time because I will be available on Zoom from 11 a.m. to 1 p.m. Okie dokie. So just keep that all in mind. And with that, let's go back into files that we were talking about last time. So we kind of ended on this slide, and we talked about ways to both read from files and to write to files. So we were using this brand new header called fstream, which gives us access to these things, ifstream and ofstream, okay, which allow you to get to read from a file and to output to a file. So we did some examples there where we, first of all, this is the file from last time, files1. We made a program to create an output file called animals.txt in our current working directory, and we noticed that we could write to it. And then after that, we didn't like that when we kept running it, it overwrote the file. So we talked about appending to files. So there's another way to use an OF stream to append to the end of a file so that we always just add an extra line as opposed to clearing out that file and getting rid of everything. And then finally we talked about IF streams, which are the opposite. They allow you to get input to read from a file. And we talked about opening up a file that we had already made and reading a single line at a time from it using this getLine function. It moved this whatever line it was currently on, it read it and it put it into this line variable. And we talked about cursors and things like that. And so I want to show you that last time we used OFS kind of like cout. And it's also quite possible, if you're not using getLine, it's also quite possible to use IFS like cin, and you can think of it that way, and I'll give you an example in just a second. So let me show you that. Let me write this down here. IF streams are, lowercase please, are quite similar to cin, because you're getting input from a file, and OF streams are quite similar to cout. You can use those arrows as appropriate. So right now we only started and we used getLine for reading from files, but I'm going to show you an example right now to do things in a different way, or maybe in two examples. I'll show you a way to do it differently, to use IFS like cin. Okay? And maybe I should just briefly give an example just to drive the point home using the file from last time, which is somewhere here, animals.txt. And the idea was that, I hope you can see my cursor right now, when you start reading from a file, your cursor, like it's blinking right now, it starts out at the very beginning. And after you call getLine just once, then it reads an entire line into whatever variable you asked it to. So some variable is now going to get stored with the text duck, and then it moves its cursor to be ready to read the next line. Okay, so I hope you can see my blinking cursor right now. If you can't, that is unfortunate. And so then if you call getLine a second time, it'll read this entire line that it's on, that it was waiting to read with its cursor when you call getLine, and then it'll set its cursor to be the next thing that you want to read. And you'll keep on doing this forever and ever, reading a line at a time, reading a line at a time, and then putting your cursor ready to read the next one until you get to the very end of the file and you read your last line. And at that point, you're said to have been reading past the end of the file, right? So get line or if streams return become false when after you've tried to read past the end of the file. That's a good way to know when to stop reading. Okay, so you just keep on checking your IF stream that you're using to read, and eventually it'll become false if you check it in an if statement like this. And at that point you can stop doing what you were doing. Okay, so now let's go into a fancier example. This is files3.cpp today. What we're going to do, the game plan, is we're going to read this file called parrotsketch.txt, and this is from Monty Python if you'd like to look this up afterwards. If you've never seen it, it's quite funny. So there's an old Monty Python sketch, and it's called the parrot sketch. And what we're going to do with our program is we're going to read a line at a time and keep on asking the user, hey, do you want to keep reading? Because eventually the user might want to stop early, not read the entire file. And for each line that we read, we're going to count how many parrots we've seen so far. So we're going to keep track of the number of times we saw the word, let's see here, the word parrot in this entire file. And you can see there's a bunch of different places where that parrot appears, obviously. It's called the parrot sketch. So we want to read a line at a time. Sorry, this is for reading, excuse me. And we're going to count how many parrots we see, and we're going to do that by getting a single line and looking inside of that line for the word parrot. If there's a line with parrot on it, we're going to increase our number of parrots. Otherwise, we'll say, no, this line didn't have any parrots on it. And we're going to do this in a loop so that the user, I'll show you an example in just a second, so that the user can input a single character at a time. And so if the user wants us to continue reading the next line, they will just type new line or something like that. And if they want us to stop, they'll type Q or something else, something that's not a new line. Okay, so let me run this program for you, and then we'll see it working from there. So what I would like to do is first of all make a makefile so we have practice for that for our midterm. Remember that files will not be on the midterm, that's where I cut everything off, but we talked about makefiles before that, so it could possibly appear. So let me make a makefile to compile our files3 file. So we're going to have our target be called files3, that's the thing we want to make, and I just won't go through the .o file this time, I'll go straight from the .cpp file, and I'll use G++ to compile that file into what I want it to be called. Okay. And now I should be able to say make files underscore 3. Actually, I could have done it before with the default rules, but now it'll definitely work. Make files 3. It'll run the makefile rule that I gave it to compile that files 3 into this executable called files 3. All right. So the idea is this program is going to open this file called parrot sketch and get a line at a time. So initially, we want to read the first line, so I'm going to set this response variable to new line. So while that's true, while response is equal to new line, I'm going to get a single line, and we'll print it back out to show the user what we just read. So we just read the first line in this file, right here. And then we are going to figure out if parrot occurs anywhere in this line. And we'll output where it occurs, the place in the line that it occurs. And this is actually outputting -1, which means parrot doesn't occur at all. So this is this find function is a special function defined on strings. So let's go to the string library. Dun, dun, dun. String. So on each string, we have a find function that we can call and look for another string. That's what all of these are doing. And it'll return back to us a special kind of type, which is essentially an integer. and it'll return back to us where in that string, what index into it, the first occurrence of that word we were looking for, or whatever string we gave it to look for, where that occurs. So if parrot occurred in this line, it would give us the starting index, because a string is just essentially a list of characters, and you can index into it. But the special case where it doesn't appear in the string you gave it, so parrot does not occur in this line, it'll return back to us the special -1 value. Okay, so this is how we know that parrot does not occur in this line. And so we'll check, hey, if it occurred, then this position will be greater than or equal to 0, and we can increment our parrots, but right now that's not true. So parrot stays 0, and we'll ask our user, hey, do you want us to read the next line of this file? And we'll use a special new function on CN called the get function. And what this does is it gets a single character from CN. You can also call this on IFX, actually. It's kind of like CN. So what this .get function is going to do is it's going to get a single character and return it back to us, and we'll put it inside of response. So this is essentially equivalent to doing this: CN, get a response, set response equal to the single character. But what that thing does right now is it skips whitespace, but that's not what we want here, because we want to check if response was equal to a special kind of whitespace, which is a new line. So we're going to use the get function instead. So I hope that makes sense. So what it's going to do is, if I type enter, cn.get will have returned this new line, because a new line is what an enter is. Okay? And so then it'll read the next line, and it'll say, all right, we still have no parrots. So our number of parrots is 0 still. And if I ever want to stop, I can just type a character that's not new line and hit new line. And then it'll tell us the total number of lines that we've read so far that included parrot. So with that, let us continue. I'm just going to type enter a few times. And eventually we're going to get to a line where at index 68 into this string, so right here, that's apparently the 68th character, or really the 69th, because they start at 0. That's where parrot appears. So now we have a line with a parrot in it. Next one doesn't have it. There's another line with a parrot. And then I can hit enter a few more times, and here's another line with a parrot in it. It's at index 7. I can hit Q, or just anything, any character, and it'll stop the program and say the number of lines that we read so far that included parrot was 3. And we can, of course, always just go to the end of the file, because if we ever hit the end of the file, we're going to stop the loop anyway. I'm just going to keep on hitting enter. Whee! And apparently, there are 8 lines in this text file that include the word parrot. And so that's a fancier example of using f-streams, and particularly if-streams, to get input from a file. So with that, let's see, I'm trying to figure out what order I want to do this in, but I think let's try to do this question now. So take a second to think about the answer. Which of the following is going to always work and it's correct? Maybe they both are, maybe neither of them are. What it's trying to do is just like get a line and print it out. So this is essentially taking the entire file, reading the entire file line by line, and printing it back out to us. Okay, so it's the equivalent of this command called cat, which prints out a certain file. So let's have it print out lecture 6/animals.txt. So this cat command just prints out a file, and essentially this loop is doing the same thing. It's printing out the entire file, line by line. So depending on what you think, let's go and figure out if what you're thinking is correct. So I've coded up option A with this kind of loop, and then option B with this other kind of loop. And we're going to use animals.txt as an example, so I'm going to copy that into my lecture 7 folder right now, because it doesn't exist here. So I'm going to copy lecture 6's animals.txt into my current directory. Okay, so now I have animals.txt right here for me to use, and so I can compile and run this program now. So I'll make, in my make file, rules for option A and option B, and let's do it fancier this time. Option A is, let's go through the .o file. Let's compile and then link at the very end. Let's make option A.o and G++. Option A .o, output it as option A, but how do you make the .o file? Well, we could use the default rule, of course, but we could also go straight from the .cpp version of this file, and then we can use the -c command on our .cpp file, and that'll work. We could also do the same thing for our option B. So I'm going to change all these to option B now. And now I should be able to say make option A. It'll go through the, it'll notice that it needs to make option A.O first. So it'll then run this rule to make it, and then finally it can do what we originally asked it to do, to make that final executable file. So I'll say make option A. So it'll compile it, and it'll notice that it needs to make the .o file first before it can do the final thing, and I'll do the same for option B. So now we can run them both, and let's see what happens. So option A, remember, we want this thing to print out to us this file, line by line. So /option A will print these out. It looks like it's doing it okay. So 3 horses at the end. Yeah, seems fine to me. Oh, it looks like I closed them both, sorry. So that was option A that we just ran. Let's do option B now. Oh, there's an interesting slight difference here in terms of the thing at the end. Let's see if we can make that a bit more apparent. So let's see here. There's a difference. I hope you notice. Let me get rid of this final new line. And I don't know, let's put another parrot in just for fun. So now, if I run option A, seems fine. Option B, ooh, that's printing out parrot twice. So option B is not working for us, and the answer therefore is A is the only one that's correctly concatenating this file to the output. So let me, oh, that didn't work. Let me circle it, first of all. And then let's talk about why B is incorrect. There's an issue that's happening right there, if that's an arrow. Actually, I think this can make an arrow for me. Boop. Oh yeah, that's beautiful. Okay, so there's an issue that goes on right in between this line and this line. So let me see if I can code that up for you, or write it up for you. So let's pretend we had our file. It was like duck and then goose. Let's have that be our entire file. Okay, so remember there's implicitly a new line here, but not a new line here. So this is our file. And if we start reading from this, of course, our cursor starts right here. We read a line that moves our cursor to right here. Okay. So let's pretend, and then we're going to print out the line we just read, right? So it'll print out initially, read past the duck to right here, print out duck. Then it'll read past goose, and it'll be like right here, but not really. There's nothing there. It'll read past goose, print the goose, right? So then, the issue is, there's a special thing. There's the end of the file that we haven't yet hit, okay? So, the third time, we're in this loop one more time, right? Because IFS is still, hasn't read past the end of the file, so it's still true. We call getLine one more time. And now, it's going to read past this end of file thing. And at that point, IFS becomes false. But we didn't check it before we printed out line. I hope you see the issue now. So the issue with option B is that the end of file isn't checked for at the correct time. Okay, so we read past the end of the file, but then we immediately assume that we just read a line correctly. We assume that getLine worked correctly when, in fact, it didn't do anything but read past the end of the file. And what happens when getLine reads past the end of the file is it doesn't reset line to anything special, it just keeps it what it was. Okay, so line stayed what it was. The line variable stayed what it was previously. And we print it out a second time incorrectly. Okay, so maybe let's put that here. Oops, not parrot, incorrectly. didn't copy. So we're incorrectly printing out that last line a second time because of the way that getLine works and the way that we read past the end of the file. Okay, so getLine is going to initially stop right before the end of the file, and then once you call it once more, it'll read past it, and then this IFS will become falsy. And the issue is, the solution is, every time you read from IFS, you better put this kind of check somewhere. Okay, and while one, remember, is just an infinite loop. While true is what it's doing here. So with that, we're at the end of the slides, and I want to do an example that I like to do every time I teach this lecture. Is usually it calls for audience participation, which is really unfortunate because I have none right now. But the idea is I want to make a translation program. So we read in a file using IF streams, and we're going to translate that into the languages that that you guys speak in the class. So I have picked my favorite song, which is Let It Go from Frozen, of course, and I was going to have us translate this, so it'll read a line, or it'll read a single character at a time, and it'll read a single word at a time, and every time we're on a word that we want to translate, that we know a translation for, into one of our languages, then we'll output that new translated word instead. So let's start coding this, and I'll just pick the languages this time. I'll use the ones from last quarter. So let's include IOStream because we're going to print stuff out. Let's call this translation.cpp. Translation, I spelled that right. All right, and then using namespace standard, include fstream because we're going to read from files. And then let's make a main function. Let us, first of all, make our ifstream object, ifs. It could be called anything, like my file, but I've just been calling it IFS for this, all these examples. So IFS, we're going to use that to open the file that we want to read from, get the input, lyrics.txt, in our current working directory. And then at the very end, we need to remember to close it, because we're good programmers, and then return 0, of course. So in between, now we want to get a word at a time from the file, and translate it if we know how to. So let's do our example. So while true, I'm going to get a single word from this file. Okay, so string word. It just so happens that if you use IFS as a, like you would with cin, if you give it a string variable to read into, it'll place a single word in it at a time. So it'll stop at whitespace is what I'm trying to say here. So if I do ifs, use that to read into word, it'll take it'll get one word now out of the file. So the first word that it reads is going to be then the next the word that it's going to read is going to be snow. And the idea is we want to see out the translated version of this word instead of the one we know, okay? And then I guess we should output some spaces. We'll fix this later. Let's call this translate. And, well, actually, it's quite possible that we read past the end of the file right here. So check to see if we unsuccessfully read, or if our read from the file was unsuccessful. That is, we read past the end of the file. Okay, so if not IFS, break is the idea here. And let me be a good programmer, a good intro programmer in CS16, and place braces around this if statement, even though there's one line in the body. Okay, so now our job now is to implement this translation function. So I'll make a string translate a string that we give it, and well, let's pretend we don't know how to translate anything right now. So let's return the word that we were given. So right now the entire lyrics are going to be in English, but I want to just show this program working. Let's use our makefile again. We want to make a program called translation. It'll take the .cpp file. We'll just go straight from that. G++, that actual file, -o, the name of the target, which is translation. Okay, I'm mixing things up now. So make translation. And let's see if I included things wrong. Let's see if there's any errors, because it's very easy to make a mistake. And it appears that this is doing the right thing for now. So yeah, it's just printing out the file a single word at a time right now. So before we fix this translation function, let's fix the white space, because we want to have it place new lines right here, right? At the end, we don't want to have it just print out one big long paragraph. We want it to print out the entire file, okay? So that will lead us to use this .get function again. So if I have an IF stream, I should have a get function on it where I can get a single character. And the type of this function is no fun. It doesn't return a character, it returns an int, but whatever, it's really a character. So instead of outputting this kind of stuff, let's get the white space and output that back. Okay, so the idea is, while the next characters in IFS are white space, read them in to advance that cursor that's reading from this file, remember. There's always that little cursor somewhere. To advance the cursor and output them right back out. Output those same characters. So the idea is, we need to check and see what the next character is. Oops. We need to check and see what the next character is in our IFS, and there's a function for that called peek. So it looks the next character without advancing that cursor. So while ifs.peek is a space character, and this is a special library file, library function that I'll talk about in a second. So while it's a space character, read it in to advance the cursor and then output it right back out. Okay? So char c, or space character, equals ifs.get this time. We'll get that actual character to advance the cursor. And then output it right back. So see out that particular space character. If it was a new line, it's a new line. If it was a tab, it's a tab. If it was a space, it's a space. So then we're going to be ready to read another line. Let's see here. Let's see, let me just make sure this is all looking okay. Yeah, let's talk about isSpace. That should be in the C library somewhere. If I remember properly, it is in CC type. There's a special function that returns a Boolean, whether or not the character you give it is a space character. So it returns true or false. The return types and the input types of these C library functions are really silly. This is supposed to be a character. This is supposed to be a Boolean, but of course those things can be translated between each other implicitly, which is unfortunate. It's really supposed to check if a character is a space kind of character. So a new line or a tab or a space. So that comes from CC type. Okay, so let's see if we run this now, if it's looking a bit better. That's looking a lot better to me. There's a slight issue I can think of if this is like the end of the file at this point, but it's possible that we won't run into this issue. It seems like it's working so far, so I'm not going to deal with it. You might want to do a better job than I did, though. because technically we're reading right here. We should probably be checking IFS. So now let's talk about our translation function. Instead of just returning the English translation, let's pick some words and pick some languages that we know and translate between them. So we'll just pick a few. So instead of snow, let's use the Spanish here. Let's use nieve. So if we ever see snow, let's return instead nieve, okay? Otherwise, we'll return that word because we didn't know how to translate it otherwise. So now if I were to compile and run this, it says the nieve glows white on the mountain tonight. That's beautiful. Okay, let's keep going. Otherwise, let's pick another word and a language to translate it to. Last time I taught this class, we picked mountain and we decided to do it in Chinese, particularly Mandarin. So instead of mountain, we'll say shan. And I'm sorry for my horrible pronunciation. So it's either shan or yama. I'm going to go through Japanese for fun. And either one of those, you get to listen to me pronounce these things horribly. I apologize. So if we see mountain, we will return this character. And otherwise, let's pick one last thing and a language to translate it to. And this can actually be an else case. It makes it slightly cleaner to just do an else case here, even though technically it was fine as it was. All right, let's see. I think what we picked last time, yeah, I wrote it down, it was kingdom. So instead of kingdom, we're going to use the German translation for that, which with a capital K is this, Königreich, something like that. And so now, this is our final translation program, and you can have fun with this. So we're translating let it go. And now we say, the nieve glows white on the shang tonight, not a footprint to be seen, a Königreich of isolation, and so on. So, please continue this on your own, but the idea is we read a file, a word at a time this time, and translated it using our translation function. So I hope that's a more colorful example of reading from files and doing cool things with them. And that brings us to the end of this files lecture, which, remember, files won't be on the midterm. Oop. Now let's talk about, in the time we have left, this fancy data structure called an array, which is very similar to the lists that you might have learned about if you learned Python. So let's get right into it. First, we need to talk about memory. So memory, it's just, this is on your right, this is a picture of what the memory arrangement looks like inside of your computer. It's just a table with addresses and the values stored at that particular address in memory. So you can think of memory as a bunch of houses, and each of them has a specific house, and you can, whoever lives there owns the value inside that house, okay? So it's a bunch of cells, they're all adjacent, they're one right after the other, and they all have 1 byte stored in them, okay? So each address in memory, 0, 1, 2, a million, they only hold a single byte at a time, so that's 8 bits, remember. And each cell in memory has a specific address, a memory location associated with it. And just to make sure that we don't forget, not all data types in C++ are 1 byte. Doubles, for example, are 8 bytes long. And so the way to store a double, for example, in memory, is to store it in 8 consecutive bytes. So if we were to store a double, like 3.14, we'd store it, if we started it at 0, the address 0, we'd use up, oh gosh, this isn't actually corresponding, 1, 2, 3, 4, 5, 6, 7. We'd use from 0 to 7. 1, 2, 3, 4, 5, 6. No, we'd use to 8, sorry. 0 to 7. This is really index 7 right there. So this would be our double from 0 to 7. This is 3.14. And we'd store it in a special way so that it took up all 8 bytes. Okay, that's the idea. They'll take up 8 contiguous bytes in memory. And there's the concept of starting at a certain address as well. That's important. So this double starts at address 0. Okay? Technically 0 is a special address that you can never access, but let's roll with this. Now, our running example is, you'll assume that you'll have completed the midterm eventually on Wednesday. Good luck. We want to store all of the midterm scores, and we want to compute the average of that midterm. So an array is a data structure that lets us store a bunch of stuff, and that's the reason for this running example. So we're going to eventually write this program. So let's talk about arrays. So C++ arrays, we'll draw them like this in memory. This will be our diagram for arrays. And an array is just a list of elements, just like a list in Python. They do share the same name. You can we'll call this array scores, for example. And everything inside of scores, it's multiple things that scores holds, but they're all of the same data type. So for example, if we're going to store scores, they should be doubles. And they're all located adjacent to each other in memory. So if I had an array of doubles, it would be a bunch of 8-byte long doubles, one after another, that made up that entire array. Okay? And so the way to declare an array of type double, holding a bunch of scores, call it scores, is this. You'll say double. That's the type of the array, the type of things inside the array. You'll say scores. That's the name of the array. And then you'll give these brackets. Okay? And let's say we wanted our scores array to have 1, 2, 3, 4, 5, 6, 7, 8 things in them. We could say it like this. So this is going to make an array called scores, an array of doubles called scores of length 8. Okay? So that'll make exactly this in memory, but these will all be undeclared. All the things inside it will be undeclared, undefined. So this is just the declaration of the scores array. If you want to declare an initialize, you could do a few things. You could do it all in one go like this. So here's an example of a scores array where you don't even give the size because you gave all the values. So it's really implicitly of size 3. So this let's see, oops, let's get rid of that highlighting. So this array, if we were to use this in memory, it would make a scores array only of size 3, whereas this one would make a scores array of length 8, size 8. All the values inside, all the 8 values inside, are undefined. They're going to be random memory garbage values, so remember that. If you want to declare and initialize, you can do this, and this is what it makes this array of size 3. This array has size 3, and you can't change the size of an array. That's very important. So this makes our scores array like this in memory. 20, 10, then 50. And there is no fourth. There's no fourth thing, which is a different index. So this is really, you can index into these arrays and get what's inside, get the 20, by going to scores 0. And this one is scores 1 there. Starting with 0, of course, because this is computer science. This is exactly like Python lists. So this is scores 0, 1, and 2. I hope that makes sense. So you can now access those elements by doing those things. And a quick example, let's reassign each element's value to 60. What we can do is, let's see here. Think about it yourself, and then I'll give an example in code. So we did that. Then all we need to do to make all of these 60 is we could say something like scores 0 equals 60. And do the same for scores 1. These are brackets, sorry, equals 60. And scores 2 equals 60. Or equivalently, you could just do it all in one go. You'd be like, I don't have that much time to write multiple lines. I can say scores 0 equals scores 1 equals scores 2 equals 0. And that'll assign them all to 0. Lowercase s, please. Okay, that's that. And then you can also increment each element by 10. And of course, if we were to run this, it would change all of these. This becomes 60, this becomes 60, this becomes 60. You could also increment each of them by 10 using similar things. Oops. You could do scores 0 equals scores 0. They're just like longer variable names. Plus 10. That's exactly what you could do. You'd also do plus equals, and you can do the same for all those other variables, scores 1 and 2. Of course, it's quite easy to loop through these things. Here is a loop. The idea is we can loop through ARR to increment those things. Oops, let's stay down. There we go. Let me give you an arrays example file. So arrays.cpp. And so the idea is using namespace standard. And remember your main function, that special kind that took command line arguments. Now you understand what this means. It's an array of char stars, whatever those are. Those are just special strings. Okay? Okay, so let's make an array. What do we call it? We're going to use ints, an array of ints. So int array 10, 20, 50. So you can use done. When you give the values, it'll set the size to 3. Okay, this will make an array, 3 things. And we can also loop through this. So for int I equals 0, I is less than 3, I plus plus. You can also do less than or equal to 2, because this is index 0, index 1, index 2. So this can be, we can use this to increment everything. So array I plus equals 10. Then we can actually go back and print out the entire array now. So what is it now? See out array I, and maybe like a space. And at the very end, we'll see out a new line. So this should print out 20, 30, 60 now after we did this. Okay, so this should print out 10, 30, 60. Let me cheat. I'll just say make arrays. Use the default rule. 20, 30, 60. Very nice. So that's that. And let me now have a demo of passing arrays to functions. This is a huge caveat, and that's something you'll need to remember for your future lab. When you pass arrays around your program, you also need to pass the length of that array. For example, in Python, you're able to get the size of an array. Or if you had used Java before, too, arrays come with their sizes. In C++, arrays don't know what their size is. Okay? It's very important that you pass along that value. So here's a function. Let's call it, I don't know, maybe print array. Let's do that. Void print array. Because then we could call it instead of doing all this. Int a, int size. So we're always going to pass along that size. So remember to always pass along the size of the array. And this is how you pass along an array variable. It's an array of ints, doubles, whatever. Just put the type of what's inside and then also these 2 brackets. When you pass along a variable, that's an array. You only ever need to say these 2 brackets like this. You don't have to say the size because the size will be in a different argument or a different parameter. Okay? So instead of 3, we're going to have the size here. And now I use A. A of I. From 0 to size, less than size. Print everything out, please. So we'll say print array. ARR. This is how we pass along the array. We just say the name, pass the array by saying its name, without any brackets or numbers. Okay, just the whole darn array, give it to him, and then the size is 3. So do the same thing. All right, so that's how you pass arrays to functions. And I'll have to remember to talk about something in just a second, but it's quite possible to change an array by passing along, which is different than what we know. But before we do any of that, let's hit these last 2 slides. So take a second to think about what's going to happen if we run these 4 lines of code. We're going to make an array called ARR of ints in memory, initially holding 1, 2, and 3. Please figure out, this will be very helpful for your second midterm, what these values are going to look like. In memory. Okay, so let's talk about this. So let's execute these lines on paper. So int array is 1, 2, and 3. It's going to be a size 3 array called ARR, holding ints. And initially it holds 1, 2, and 3. Okay. Then we're going to set a temporary variable to hold whatever was in array 0. And array 0 right now holds 1, right? Remember, because the first index is 0. So we're going to make a new variable called tmp. It's a single integer, and it's going to hold whatever array 0 held, which is 1. All right. So now we're going to set array 0 to be whatever array 2 was. So array 2, remember it's 0, 1, 2. Array 2 is 3, and we're going to set array 0 to be that 3. Okay? That's what happened there. And now this final line is saying array 2 equals whatever temp was. So temp is 1, so array 2 becomes 1. So this is essentially, for this 3 element array, it's reversing the array. Okay? So the answer is in fact C. And if you code this up, it should you should be able to print out the array and see it work. So make sure that makes sense to you. And now let's talk about this question. So see if you can think of the answer on your own. Take a second to pause this, because this is very helpful if you can intuitively figure this out. But if not, don't worry. I'm going to give you the answer and talk about it because I haven't given you a lot of information about this. You technically have, I think, just enough hints to hopefully have a slight idea of what's going on here. But you might have to consult a table from the textbook. So it just so happens that, remember how we were talking up here, like doubles, well, those are 8 bytes long. That's important because ints, they're not 1 byte long either. So let's pretend we have this scores array, int scores. Now we need to remember to write this scoring program still. One, two, three, four, 5. Only 5, sorry. Go away. How about that? 10, 20, 30, 40, 50. Doesn't really matter. So in memory, this array starts at a certain address, and the starting address is where this 10 lives, all right? Because these are all in contiguous memory, growing that way. So if this was an array of characters, say, starting an address like 12, then the next thing would be 13, because characters are 1 byte long. This would be 14, this would be 15, this would be 16. But we're saying that scores starts at address 200 in hexadecimal. If you ever see 0x, by the way, 0x, blah, 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 means, is a prefix. That means the number following is written in hexadecimal and should be interpreted as a hexadecimal number. So this isn't 200, this is 200 in hex, which is 16 squared times 2. Okay? So whatever that is. So the idea is we want to know what's the location of the element at index 2. So if this is where the 10 starts, it starts at address 200, we need to think about how long ints are, because we need to figure out the starting address of this 30 variable, which is an int still. So if you look up in your textbook, or just remember from a time long ago, ints take up 4 bytes in memory, which means that each index gets incremented by 4 because it took 200, 201, 202, 203 to store this first 10. It took 4 bytes of them, 4 bytes to store an int, which means that this index 1 is going to be 0x204. That's the starting address of this new integer. It'll take 4 bytes itself, so 204, 205, 206, 207, and then at 208 is where this 30 starts living, from 208 to 20b, right? 9ab, yeah, okay, I think. So that's the idea. It starts at 208, actually. So keep that in mind. Integers take up 4 bytes. And if you didn't remember, there's a helpful little command, a little keyword in C++ that tells you how many bytes a certain type takes. So size of.cpp. Let's erase most of this. So there's a special keyword in C++, the size of keyword. Treat it like a function. Returns the number of bytes in a certain type, or variable for that matter. But usually we'll just use types. So we can see out size of double equals a certain number, and we can just output that right here. Line. Let's do the same for int char. We learned some other ones once upon a time, didn't we? We'll never use them, like float and short and things like that. But here are the standard ones. Oh, maybe bool. What does that do? All right. So make size of. And it just so happens that doubles take up 8 bytes, ints take up 4 bytes, characters take up 1, floats take up 4, and booleans, even though we'd really like to use just 1 bit, we have to use the whole byte because we can't address into memory or access memory with any finer granularity than 1 byte at a time. Okay, that's that. Let's see here. I think that's what I wanted to say there. So that's size of, and we're essentially at the end of these slides. Let me take a look at my notes to make sure that everything that I wanted to talk about, I have talked about. Yes and no. So first of all, we still need to do this average of midterm example. So let's do it over here. Let's make this our scores right now. Let's get the average of the midterms. So let's say double score equals. Let's say it was 10, 20, 30, 40, 50. So the average should be 30, right? 20, 30, 40, 50. And then we'll iterate through scores with plural to calculate the average. So int 4, int I equals 0, I is less than scores length, which is 1, 2, 3, 4, 5, I plus plus. To calculate an average, we need to sum up things. Sum, started at 0. Sum plus equals scores I, and at that point we can say double average equals sum divided by 5, and then we can see out average, which should be 30, is AVG, new line. All right, cool. So that's working for us. That's one thing I forgot to do. We talked about size of. I want to talk about something for your next homework so you can get started and do it all, but we'll talk about it more later. Also about makefiles, something that might come up in one of your future labs is you can make a special like fake target called clean. That's the general, that's the normal name. And you can use that to delete all of your compiled files. So clean is the, like, it's the historical name. It's the common way to, it's the common target that deletes all compiled files. And I think I gave an example of this before, but you'll use the remove command. Remove everything .o and don't complain about it. Use -f. And we'll, like, binaries maybe. So we can make a bunch of binaries in this entire thing. So files3 is a binary that we made. It's an executable program. We might want to delete it with the clean command. Option A. .o files will get taken care of with this wildcard thing here. Option B. And then translation. And so clean, if I say make clean now, it's going to remove all of these things. So here they are, some of them, and here a lot of them aren't now, like arrays and size if I cheated and didn't use this make file for them. But another thing you can use this binaries for is you can make this first keyword. Remember, that's the first rule in a makefile, is what gets run when you say make in the terminal without anything after it. So it's customary to call the first rule all that makes everything. And it's going to make all the binaries, please. So if I say make clean, and then if I say make now, or if I say make all, because it'll do the first rule, it'll compile all of these binaries, because that's what I said. Hey, all requires those, so please go off, find their rules, and make them all for me. No, shoot. No, I don't want to make binaries. Sorry, the variable. I want to replace that variable with all these things. Excuse me. And then it goes and it makes all those binary files that we asked it to. This is a customary thing you'll see in your labs, and this as well will be helpful to just start from scratch, recompile everything, please. That clean rule, okay? And with that, I want to give just one final example, which has to do with call by value and call by reference, is what we say, and that's part of one of your future homeworks. So I have to do a bit ahead of. I have to work a bit ahead because this week we only have one lecture. So let's see. I'll call it references.cpp. So I'll include most of this stuff. It's just boilerplate. And what I'm about to talk about, I will go in more detail in a future lecture. Please don't worry about that. I just want to get you started on your homework because you'll read about this in the textbook, sure, but it's always nice to have an example too. So let's make some functions. Void increment int x. Well, let's say int y. Y++. Void increment ref, or actually increment value. Val ref. That is the key, that ampersand. Int ampersand y means that y is a reference to an int rather than just another int. So here's my variable x, 42. I'll call increment val on it. Call by value. Copies stuff. Then I'll say, then I'll print out x. And then I'll say, well, increment ref this time. Same x. Whatever. Same x. Print it back out. This is call by reference. Changes stuff, you can say. Okay, so let me show you this running. make references. And then hopefully we can stop, and I haven't forgotten anything, but there will definitely be a part 2 if I did forget something. So the idea is increment val copies x into y, and y gets incremented, of course, but that doesn't affect x. But increment ref is doing this call by reference thing, where we use this ampersand, and y is x at the same time. Y is x. It's just another name for it. And actually, this y++ touches the original x. So y was a way to talk about x in this function. And so we were actually able to, with that function call, to increment x. And here's the idea. If I go back to my handy-dandy call stack, I have my main function. And it had its x variable set to 42. And then if I used increment val, well, it made a new variable called y, and it copied x into it. So the call by value function made a new variable for its parameters, and copied the argument x into y. So those are separate places in memory. Incrementing 42 to 43 here does nothing to x, all right? So this was call by value. And that was the one thing I did forget, so thank you for reminding me. Hopefully I'll remember it after this as well. This is called by ref now. Reference. The idea there is this other function in main. Still we had x set to 42. But the idea was when we called increment with reference, I will put this in blue because this is hard to draw in this kind of diagram. The idea is there is no separate y variable. Y is another name, so that's why I'm putting this in blue. Y is the name that incref uses, increment references, uses to talk about that same variable x. So that's the kind of picture you can draw here. You need multiple colors to do it. So now when I say y++, well, yeah, sure, y is x, 43. And that's what you're getting there. And the book talks about this too, so hopefully that's a good start. There's one more called by address, called by pointer, that we'll talk about in a future lecture. But that's enough for this time. And one thing that I do want to talk about is what happens when you call a function with an array. When you pass an array to a function, arrays are special. You can actually, that array doesn't get copied. And the reason for that is, suppose that you had an array of size 1 million. That would be very inefficient and bad for your computer to copy that over. It would be very slow. So that's why arrays don't get copied across program, or across function calls. So that allows you to change the values in an array using a function call. You don't have to do this weird call by ref thing for arrays. You can just give the array still, and you can actually change those things. So for example, let's change this print array function to be like print array and increment too. Or let's not. Let's make a copy. Increment by 10 or something, like we did before. So before we do any of this, let's you know what? Let's just make an increment by 10 function. Why not? Still a void type. Not doing anything other than an effect. So a of I plus equals 10. So this is actually touching x. This is changing the array you passed in, which is different than what you'd expect, because size, for example, is just a copied value. It doesn't touch it if you had a size variable down here in main. Okay, so this is actually touching that array. All right, So we can print the array, and let's call the increment by 10 function on it, and then print it again, let's say. And that should be everything, in theory, that I wanted to talk about. And if not, I'll see you in part 2. So yes, this is incrementing by 10 in the function, because when we passed the array, it actually got to touch that array and manipulate it. And that was in stark contrast to this kind of call by value thing that we're used to doing now. We're learning about new stuff. We'll learn about more kinds of doing this kind of manipulation. But arrays are a bit different, and passing an array actually allows you to change that array. Okay, so I think we've covered everything I wrote down, and with that, I will see you next time. Good luck on your midterm.